So.
I think chemicals will be fine.
Yeah, it will be. It's just that it's sometimes catches people off guard with how much harder it is. That's all. It's not impossible.
That's reassuring.
So we finally finished up our logarithm stuff. So other than semester exam, you're not going to meet the requirements to exempt that. I guess you'll have to worry about it for that. Otherwise, we won't need to use any more logarithm stuff the rest of the year. But so we have some different algebra skills to do now. So we are actually going back to the very, very first part of the textbook, which was section 1.1. And this is a one-day lesson, so at least half of this stuff should be very familiar to you, all the way back as far as Algebra 1 even. And a couple of things you just may not have done in Algebra 1, but they're really Algebra 1 topics. So, worksheet 1 today is handout 102. I'm going to go through all of that with you as a quick little reteach and to show you a couple of those things for the first time. Then I'll give you a chunk of time to try basically the same question types on handout 103, which is worksheet 2. We'll check those answers, see what you need to ask about, and then finally 104 is a short one and is extra practice. And it's some extra practice on the question types that students usually feel less comfortable with. But again, this is just a one-day lesson, so we will quiz over this stuff next class. Quiz will come from questions like these 3 handouts. Okay, so starting off with this worksheet 1, questions 1 through 4 want us to write an equation of a line that meets these requirements. And so there's a few different things that are going to come up here. So looking at like question 1, it says you can put it in any of the 3 formats that you may have learned in Algebra 1 or Algebra 2. But the main one that I'm going to focus on, and it's probably not the one you're most familiar with, is called point slope. In higher mathematics, this is the one we really like to use the most, honestly, because it's the easiest. Okay, so what all you need for point slope is you need a point. So in question 1, we've got 2 to pick from. So you subtract the y value here. So if I use this first point and then subtract the x value of the point there, minus a -1 becomes a +1. Or if you'd rather use the second point, that's okay too. So you'd still subtract the y value of the point, minus a -3 becomes a +3, and then subtract x here. And then the only other thing that you have to be able to do for this is to find the slope. So you could either make a graph and count rise over run if you want to, or we can use slope formula, which is good for you to know for the ACT anyway. So subtracting the y values gets you the rise, and then subtracting the x values gives you the run. The most common mistake is flipping these two. Difference in y's over difference in x's. So if I do that down here, second y minus first y over second x minus first x, looks like the slope comes out to be -3. So for point slope, that's all you have to do. Now, I don't know why you would do this, but I will verbalize it one time. I guess if you really wanted to put it in slope intercept, you could. You're going to have to do more work to do that, which is why I don't understand why you'd want to. But to get this in slope intercept, you could distribute the -3 and then add the 6 over. And if you did the same thing to this, you'd still get the same answer. So it's not hard to put it in slope intercept form, it's just not necessary. Point slope is preferred. And you don't have to write both of these. One of these is fine. It just doesn't matter if you use the first point or the second point. Okay, let's skip down to question 4 because it kind of looks the same. It's got 2 points. So just like in question 1, let's go ahead and find the slope. Oh wait, I did not do that correctly. One thing about the slope is you have to be consistent. So if I did this y value minus this y value, oh no, I'm sorry, I did do it okay. Then it needs to be this x value minus this x value. That's fine. So it looks like the slope is 5/2. Again, you could make a quick little graph and count rise over run to get to those 2 points. But y minus the y value equals the slope times x minus the x value. So just from here on out, I'll just use the first point so we don't have to double our answers, but it's also fine if you use the second point. Now, technically, because this is minus 0, we probably wouldn't leave that there. That would be point slope. And if you're just really determined to add the 5 over to make it slope intercept, that's okay too. But especially for those of you doing calculus next year, I don't know if this is true for AP Stat. It's not as true for college algebra, but calculus point slope is pretty much the only thing we use when it comes to this type of stuff. Okay, so before we move on, is there any questions about slope formula or point slope form? I assume you've all at least seen point slope form. Probably just didn't use it that much. Okay, so back to question 2. So you do need to know some stuff about vertical and horizontal lines. Some of this stuff has come up several times already this year. But a horizontal line looks like this. A vertical line looks like this. Because it's flat, this guy has a slope of 0. If you try to do rise over run here, this guy's slope is undefined. But for a question like number 2, you need to know that a horizontal line has a slope of 0, so that you can do like we did on the last questions. Y minus the y value equals the slope times x minus the x value. See, distribute your your 0 and add the 5 over. So really, anytime you have a horizontal line, your equation is just going to be y equals a number. So if you wanted to go through -1, 5, it needs to be y equals 5. But you don't have to memorize that because you can just do what I did. But you do have to know that horizontal line has a slope of 0. Over here, vertical lines always have an equation of x equals a number. We will need that before we are done with this worksheet. Okay, and then question 3. So if we're sticking with point slope, we know the y value we wanted to go through, we know the x value we wanted to go through. Really the only thing that's going to slow us down is trying to find the slope. Now this one asks it to be perpendicular to this line. So since this is in mx plus b, I can see the slope of this guy is 4. So you need to know that parallel lines have the same slope. So if this said parallel, I would use a slope of 4. Perpendicular lines have opposite reciprocal slopes. So reciprocal means you flip the fraction over. Opposite means it needs to be the opposite sign. If this guy's positive, this guy needs to be negative. So I think most of you probably remember that, but if you don't, you need to write that out in words. Opposite reciprocal. Opposite sign, reciprocal fraction. Perpendicular lines always have opposite reciprocal slopes. Okay, so let me pause for just a second here. So for questions 1 through 4, any follow-up questions y'all need to ask? Okay with this? Okay, then 5 and 6 is a couple that I suspect you probably have not heard before. It's not that they're difficult or anything, but it's just some topics that come up that you need to be aware of. You're supposed to see it in Algebra 1, but a lot of times teachers run out of time in Algebra 1. So when you see this, direct variation, that means that it goes through the origin. It's understood to go through the origin. And instead of using m for slope, we like to use the letter k, but it still means slope. So in question 5, as long as you know direct variation goes through the origin, this is no different than questions 1 or 4 that we already did. We could do the slope formula to get the slope. We could subtract the y value from y, put the slope times x minus the x value we wanted to go through, and then it is already in point slope form. So direct variation goes through the origin, and the slope is often referred to as k. K is what's referred to as constant of variation. So again, for number 5, all you need to know is that it went through the origin, and then it's no different than question number 1. All right, 6, we've got a 2-part to this question, but same idea. So it says direct variation, so I know this guy goes through the origin. I'm supposed to find the value of y when x is -2. That's one question that they're asking for. And they want me to find the constant of variation. So constant of variation is k, which really just means slope. Well, they gave me 1.00 by saying it's direct variation, and then they're giving me another point when x is -1/3, y is 6 to work with. So I've got plenty of information to find the slope. Can subtract the y values. Let's see. Looks like that's -18. Just dividing fractions, same as multiplying by reciprocals. So that slope, can still find slope the same way, just on direct variation questions it's not going to say slope, it's going to say constant of variation. So there's one question that we need, or one answer that we need. And then for the second part, we could make an equation and then solve that for y. So if I know the slope, and I know one of the points is, I don't know, 0, 0, I could use this point as well. It's just that that point has a fraction in it, so I prefer not to. This equation of the line basically tells you all the points that are on there. So all of the y values come from multiplying the x value by -18. So if you want to know when x is -2, looks like y would need to be 36. So that's the second half of that question. Once again, if you are determined to do slope intercept through all of this, that is fine. It's just you are going to be making more work for yourself. So I'm not going to address that much, but there's certainly nothing wrong with it if you're doing it correctly. Okay, so this is one of the topics we will practice just a touch more at the end of class, just because you probably haven't practiced it before. It just requires a little bit more practice. But let's move on to the graphing part. So if I asked you to graph question 7, I guess you could make a table and you could plug in x values and solve for y and plot one point at a time. But I think what most people would do is they would probably switch this to be slope intercept by subtracting the 2x over and dividing both sides by -3. And of course, the nice thing about slope intercept is you know the y-intercept at just a glance, and then using the slope you can count up that much and write that much, and you only need 2 points to define a line. So you can go up 2, right 3, up 2, right 3, up 2, right 3. You can do it multiple times to make your graph look a little bit better, but if it's linear, you only need 2 points anyway. So that would be my suggestion. Solve it for y equals so that it's an mx plus b. B is your y-intercept. There's 1 point. Use your slope rise over run to get your second point. Okay, for question 8, we already talked about this on the first page. This has to do, since this is x equals a number, I know that this is a vertical line. So no matter what y is, x is 4. So that's an easy question, but again, it does require that you recognize it. Okay, number 9 is a piecewise function. So this will be one of the, I picked out 3 topics for us to get extra practice on at the very, very last handout. But piecewise functions are not nearly as hard to graph as sometimes you guys make them out to be. It's just really you have to graph like multiple parts and then keep the different pieces that you need. So sometimes your line is y equals -4. That would be a horizontal line. Sometimes your line's y equals 3x minus 2. That's slope intercept. Plot the y-intercept, use rise over run to find the second or third point. And sometimes the line is y equals 2. Y equals a number is just a horizontal line again. But this can't be your final answer because this says the function f of x. And we know it to be a function and it has to pass the vertical line test. My answer as I have it currently drawn does not pass the vertical line test. It's not really a function. So that's what this stuff out to the right is. It's really only supposed to be y equals -4 when x is equal to -2. So that's a closed-in circle, and less than -2. It's not even really supposed to exist. So you need to take that part away. It's only supposed to be 3x minus 2 when x is greater than -2. So that would be an open circle because it doesn't include it. And less than or equal to +1. So it can equal +1, so that's a closed circle. And it can be all of these values in between, but nothing to the left of -2 and nothing to the right of +1. It's just that piece of the function. That's why it's called piecewise. And then finally, the last line, y equals 2, should only exist when x is greater than 1. So it doesn't say equal 1, so that has to be an open circle. And greater would be all of the stuff to the right. Shouldn't exist to the left. Now, my graph is a function because it does pass the vertical line test. Any vertical line you draw is going to hit the graph at most once. Even right here, notice at x equals 1 it hits here but not there. At x equals -2, notice it hits here but not there. So that gives you a hint that if it doesn't pass the vertical line test, it can't be a function, so we couldn't be calling it f of x. But that's how you should approach it piecewise. Just graph all 3 parts, keep this part of this one, that part of that one, that part of that one, and if it's a function, you can check by doing vertical line test. Okay, for number 10, we got absolute value of x, and then this -1, as we know, is going to shift it right 1. So absolute value of x is 1, is a parent function that you really are supposed to know what it looks like. And then again, we're just going to shift the whole thing right 1. So I'm not sure why that one's important enough to get put on here, but it is. So. All right, down to question 11. change the slope-intercept form, which is what I did on the top left of this page. Slope-intercept form is when you get it in mx plus b. So putting it in mx plus b is not usually my preferred thing. I prefer point slope, but if the question says slope-intercept, we have to do slope-intercept. So for that, you just need to algebraically manipulate this. Subtract the 2x over, divide both sides by -5, so everything gets divided by -5. Excuse me. And then you have it in slope-intercept form. I feel like that's a good skill to have anyway for the graphing. So I will give you guys a chance to speak up here in just a second, but I'm going through a lot of that part pretty quickly because, again, you should have, I know it may have been a couple years, but you should have done those type of things to death in the past. All right, and then finally, changing an absolute value function into a piecewise function. This is kind of handy a few times in calculus to kind of help us see what's going on. So before I work this question, let me show you the classic one, and we'll do the same one on the last handout as well. But the classic one is absolute value of x, because everyone knows what it looks like. We just talked about that just a second ago. And so you can say the same thing in two pieces. You can split this graph into two pieces. You've got this piece that has a y-intercept of 0 and a slope of 1, so 1x plus 0, and the plus 0 doesn't change anything, so I'm going to take it away. And then you've got this line that also goes through a y-intercept of 0, and he has a slope of -1, so negative x plus 0. I'm going to take away the plus 0. So this one exists when x is bigger than 0 to the right, and this one exists when x is less than 0 to the left. Now it makes it a little bit easier to see because I have those color coordinated for you. This one exists during this time, this one exists during that time. But if we do this, then there would be a hole here, and there's not really supposed to be a hole here. So you either need to include here or include here, but not both. But we need to make sure that we hit this point from one of the two, but not both of them. So you can include the equal sign either way. Now, what this has to do with question 12 is it helps me show you some of the structure of how the answer comes about. So this is going to have a similar V shape, except it's going to be shifted right some. It's going to be shifted right 1/3, I believe, something like this. But to come up with the piecewise function, the two parts, it's not as bad as you might think it is. Because this, well, let me try to do same colors. It's over here. Look at this. On this one, the basic example, if you pretend like the absolute value signs are not there, that gave us one of our equations. So if I do the same thing here, pretend like the absolute value signs are not there, one of our equations is 3x minus 1. I know it's this one and not this one because this has a positive slope, that has a negative slope. And then this one was what was under the absolute value sign, but the opposite version, because if it's negative, the absolute value just makes it positive anyway. So we want the negative version of this, which would be negative 3x plus 1, just multiplying it by a negative. Which makes sense with my quick little sketch here. Looks like he has the correct y-intercept. He's got a negative slope. All of that looks good. But I can see that this one with the positive slope exists when x is bigger than some number right here. And this one exists when x is less than that same number. So I'm really interested in when are they switching spots here. And I need to make sure I include one of these two, it doesn't matter which one, so that we can hit this middle point. But to find that point, all you have to do is think about where does 3x minus 1 equal 0. because that's this line. So when does he have a y value of 0? That would be the x-axis, which is what this is, and that's at 1/3. So to the right of 1/3 is this equation, and to the left of 1/3 is that equation. But there, again, there's kind of a process to finding these parts. The stuff under the absolute value is one of your equations, and the negative version of that is your other equation. Much easier than trying to just reason through it in every single question.
Why is the bottom one equal to and not the top?
It can be either one.
Oh.
It's just that if you don't include it, then there's a hole there. If you include it twice, it doesn't pass the vertical line test because you're hitting that point twice, but it doesn't matter. You just need to include it on one or the other. Okay, so again, I think the direct variation is probably different for you, but there's very little you have to know for that. I feel like writing this as a piecewise function is probably new for you, but there's a bit of a process that helps make that a little bit easier. And graphing piecewise functions, you probably have done a little bit of that, but not a ton like this. So just graph the different parts and then practice keeping the parts. So that was just a quick little refresh, and now I would like you guys to try worksheet 2, which is a lot of the same stuff. And I'm going to freeze my screen here and work it out at the same time as you so that we can quickly check answers, and then we go over all the parts that you need us to go over. I think all of it's the same. Questions 1 and 2 are not from worksheet 1, but obviously you can ask about those if you're not sure. So go ahead and take about 15 minutes here to go through worksheet 2. Check the answers, let you ask the questions, fill in the gaps, and then on the last handout we will practice the 3 things that students still usually feel the most uncomfortable with. Looks like we may need just a couple more minutes. Okay, let's go ahead and check your answers and give you a chance to ask the ones you'd like me to go over with you. So the first two did not show up on worksheet 1, but they were just about finding points. So 17 and 2. Anything that you missed, just go ahead and circle it, put the right answer out to the side, and then you can ask in just a minute. So that way we can move along. So number 1, 17, number 2, 2. Then number 3 and 6, finding equations of lines given 2 points. Number 4, finding an equation of a line knowing that it's a horizontal line. And number 5, finding the equation of a line given a point and a line you would like it to be parallel to. And question 7, because it said direct variation, they indirectly gave you a second point of 0, 0. So that made it like question 3. Number 8 was expecting 2 answers. Constant of variation, which is just a fancy word for slope, was -8. And when x was -3, y would be negative, or when x is -3, y would be 24. Okay, and then the graphs. So number 9, I switched it to slope-intercept form to help me graph. Number 10, I recognize that equation as a vertical line, so that's quick. Number 11, you had to do 3 different pieces. So sometimes it was y equals 4. Sometimes it was y equals -2. Both of those are horizontal lines. And sometimes it's 2x minus 3. And then number 12 was absolute value of x graph, which is the V shape shifted right to. Solve that for y equals to get it in slope-intercept form. 2/3 x minus 1/3. And then 14, the piecewise function. Part of your equation should be what's under the absolute value sign as is. The other half should be the opposite of that, so multiplied by -1. And then you got to think about when each one of these occurs. So I thought about when this would equal 0, which is where I got the 4/3. You could set either one of these equal to 0 and solve to get 4/3. And then because this one had a positive slope, I wanted its values to the right of it, and this is the one that has a negative slope, so I knew that's where I wanted x values less than that because it was to the left. Okay, so before we move on to the last handout, which of these questions would you like me to go over and explain now? Number 3. Okay, so coming up with an equation of a line, if you try to do point slope, which again is just the easiest, so I'm not really sure why you wouldn't do point slope, you need a point. So I just used the first point by default. You could technically use the second point though. So plugging in -4 for x minus a -4 makes this look like a +4, minus 5 over here. That's how you plug in the point. And then the other part you got to substitute in is the slope. And to get the slope, you could make a graph, plot those points, count rise over run. As long as you do that carefully, I guess it would work. But the much quicker way is to subtract the y values to get the rise. Then at the same consistency, subtract the x values to get the run. And then I reduce that to -4/3.
How do you know which value to put first?
On this,
Yes.
it doesn't matter, but you just have to be consistent. So I called this point 0.1, so x1, y1, and that makes this x2, y2. Whichever point is 0.1 gives you those, whatever you call 0.2 gives you those. But if I switch those, you need to see that it's the same thing. So if I did this y minus this y, you end up with 8, and this x minus this x gives you -6, but that still reduces to -4/3. The only time it will mess you up is if you're not consistent. Like if you do this y minus that y, and then you switch the pattern and do this x minus this x. So.
Does it matter which set of points you use, like in the final? It's
No.
the same thing.
Yeah.
Okay.
If you want to use the second point instead, that's fine too. I just do the first point just so that you guys know what I'm gonna use, but any point is fine. Okay, Noah, was that enough? Okay. Which other ones would you like to discuss? Dylan, you got all those?
Yep.
Okay. Okay, then let's move on to the last handout, and I'll try to give you a few minutes to look your stuff over to be sure you don't have any questions, but not anything new on this last handout. It's just the questions from teaching this class enough years that I know that students struggle with the most. So let me reteach one more time. I'm going to do direct variation with question 1, and then I'm going to ask you to try it one more time on question 2. I'm going to show you how to do graph a piecewise function one more time, and then ask you to try one more. And then I'm going to show you the basic changing an absolute value sign into a piecewise function like I already did on worksheet 1, but I'm going to do it again. I'll show you if it's not just absolute value of x, and then ask you to try it once more. So again, that for most people, these are the questions they find to be the most difficult. So, all right, so direct variation goes through the origin and the constant of variation, which is sometimes called k, just means slope, and that's really the only unique things you need to know about direct variation. You got to be able to do your other stuff too, but that's what's unique about these questions. So if I want to find the constant of variation, which would be the slope, I could use this point and this point, subtract the y values, and then in the same pattern subtract the x values. Divide your fractions. Dividing by a fraction is the same thing as multiplying by the reciprocal. And then I could put this into an equation. So y minus the y value equals the slope times x minus the x value. And the equation is like a formula that tells you all the points that you may want to know. The second part of this question wants to know what is the y value when x is -5. So if you have this, plug in -5 for x, and you can see that the y value when x is -5 would be 40. So still slope formula, still making the equation of a line, still taking the point off of that. But to even start, you have to know direct variation goes through the origin, and when it asks you to find the constant of variation, it's asking you to find the slope. Just a different term, same process. So for one more practice question, go ahead and try number 2, just like we did question 1. And then at that point, I guess if you still don't feel 100% comfortable, then you might need to mark that one as homework to look back over. Okay, looks like your two answers here should be 3 and 9. 3 was the constant of variation, because that was a slope. Make sure you're careful with dividing fractions here. You don't have to do that in one step. Remember, dividing a fraction is like multiplying by its reciprocal. I turned that to an equation, simplified the equation, and again, the equation is like a formula that tells you any point on the line. So if you want to know when x is 3, you plug in 3 into it and then solve for y, which is where the second answer, 9, came from. Okay, this is the last one of these we're looking at today, so anything y'all want to ask about that? It's not like this will be a lot of points on the quiz, but it would be a couple, 3 or 4 maybe. So. Okay, then the next to last one, graphing a piecewise function. So again, I'm going to do the first one for you and then ask you to try one more of them. So piecewise function, you can just start off by graphing the 3 different parts. Y equals 5 is horizontal, y equals -6 is horizontal, y equals any number is going to be horizontal, and this one in the middle is mx plus b, so you need to slow down on that one. Has a y-intercept of -5 and a slope of 2. So up 2, right 1, up 2, right 1. So if you can graph those 3 equations, you're almost done. The only thing that you have to do in addition to that is remember that you should be only keeping this part of the red line when x is greater than or equal to 4, not less than. The bottom one you should be keeping when x is equal to -2 or less than -2. So all the stuff to the left of -2, but not to the right of -2. And then the middle one should only exist when x is -2. Oops, -2 is down here to +4. Now it's not supposed to equal -2 and it's not supposed to equal 4. So both of those are open circles, but it shouldn't exist any further to the left of -2, and it shouldn't exist any further to the right than +4. And again, it's not like this is required, but because this is a function, your graph better pass the vertical line test. Even at x equals 4, even at x equals -2. It can only hit your graph at most once, otherwise it's not a function. If it's not a function, we couldn't call it f of x. So that helps you catch some of your errors perhaps. Okay, so try that one more time for me on number 4. Okay, so part of your answer on this one should be y equals x, which would look like this, but you should have only kept it when x is equal to 5 and greater than 5. The middle equation is y equals 2, but you should only keep it where it is less than 5, so open circle, and greater than -4, open circle. Should only be these between those two x values. Notice how it doesn't include -4, it doesn't include 5, so those happen to be open circles. Hit that line though. And then finally, one more time, the last line is -x minus 5, which would look like this. But you only keep it where x is equal to -4 or less than -4. Shouldn't have anything to the right of -4. So, assuming you can graph those lines, and assuming you can read these inequalities and you can keep just those parts of each one, then you can do these question types. I guess they're a little bit longer, but shouldn't be any more difficult than graphing any other line. Okay, any specific questions about this one before we move on to the last skill to review? Okay, then the last one that students often feel a little bit less comfortable with, because you probably didn't get to this in Algebra 1, is taking an absolute value equation and changing it into a piecewise equation. So, the short answer is take what's under the absolute value sign, and that's one part of your piecewise function, and then the opposite of that, so multiply it by a negative, gives you your other function. Then of course you need to keep this sometimes where it changes and this sometimes where it changes. So for this one, the classic example, it's good to know what the graph looks like, so you can see that it's changing at 0. And to know whether this one's supposed to be greater than 0 or less than 0, and if this one's supposed to be greater than or equal to 0, this visual here should help you. Positive slope, which is this guy, is when x is bigger than 0. Negative slope, which is this guy, is when x is less than 0. And then to make sure that you don't miss this point x equals 0, you need to include one or the other, just not both. So to do the same thing on number 6, on a harder question, harder equation, again it's an absolute value graph, so I know it's going to look like a V. It's going to be shifted left some, so I'm not going to even try to make it look accurate, but a visual helps. The quick parts of this should be just like over here. One of your equations is exactly what's under the absolute value sign. That's for when it's positive. Or all of this could be negative, and then the absolute value sign could be making it positive. So the exact opposite, multiply the whole thing by -1. And then you need to write out the restrictions. So right here, it's changing from one to the other. So to know where this is when the y value equals 0. So you could either set this equal to 0 or this equal to 0, because they're both there at that spot. And that is at -1/2. So it is changing places at -1/2. We just need to think about which way this should open. Looks like positive slope is the x values to the right. The one with the negative slope is the one where the x values are to the left of x is -1/2. So a little bit of a graph helps, doesn't have to be super accurate, but parts of this answer should come pretty quickly, and part of it you should be slowing down and being kind of careful on. So try that on number 7 to make sure that it goes okay, and if not, then at least ask me what you need to ask. Okay, so the quick parts of this should have been starting your piecewise function. Part of your equation should be 4x minus 2, the stuff under the absolute value sign left alone. And then the other one should be the exact opposite of that, so multiplied by -1. That should come quickly because that's in all of these. The restrictions, though, can be a little trickier. So if you know what absolute value of x looks like, this minus means it's going to shift it to the right some. But the main thing about a picture is it helps you see that this part that has a positive slope and this part that has a negative slope switches right at this x value, or at this x value, which is when y is 0. So you can either set this equal to 0 and solve, or you could set this equal to 0 and solve. You're going to get 1/2 either way. So x equals 1/2 is where it is switching from the negative slope to the positive slope. Then we need to make sure that we open these up the correct way. So the negative slope stuff is to the left of x equals 1/2. The positive slope stuff is to the right of x equals 1/2. And then you need to include one of them, either one, to make sure that you get this point and don't skip that point. This is what you were aiming for. Okay, anything that jumped out at you about this one that you need to ask? Anything I can help clarify? Okay, I will switch it back to the agenda here in just a second, but again, this is just a one-day section before we quiz. So next class, you need to expect a quiz like worksheet 1, worksheet 2. They basically look the same. Same type of questions. Some extra practice. Hopefully helps you with the ones that you think are most difficult. But part of the reason we go so quick is that you should remember stuff like slope formula, writing the equation of a line, vertical lines, horizontal lines. All of that stuff you learned a long time ago. We're just trying to refresh you. But also there's a couple new things in there. So make sure that you have that marked up in a way that you know what you need to study. And this is a B week, so I will not see you guys again until next Monday. Today is only Wednesday. So good idea to put a reminder in your phone about the quiz next class. And of course, if you can find anything else I can help with, please let me know.